So when we push the start button, the car is on. As you can hear, the engine is running, but cluster is not working and it's connected properly. I connected the cluster. Our goal is to determine, was it the bad cluster, poor connection, or any wiring issue. So it was definitely the bad cluster. As you can see, this cluster works, and we need to transfer the mileage from the previous cluster to this. This process is like taking me to disassemble everything you can see here on the roof. Yeah. So the interior looks like this right now. Here we have our cluster from junkyard. That's the EPROM. We need to transfer or the EPROM itself, I mean the IC chip, or data from the IC chip. But as you can see, that's S93A86, and I believe it's a Seika manufacturer. And I see I don't have S93A86 in the list of this programmer. Actually, I have a few more, but because of the blackout that was caused by storm, I took everything to my home. I mean all the equipment that I got here, and now I will just go by the easiest way. I'll just transfer the chip from the old board to the new board, and I will start with the new board. I will desolder it out of here, and I already cleaned the pads here to make sure the flux will go to our solder, and it will be removed easily and without any damage to the circuit board. Also, I will use Kapton tape right now. So I used Kapton tape to protect the components around the place I would be desoldering. I used an air gun with a temperature of 400 degrees by Celsius, and these type of pillars. So they are very tiny on the ends. As you see, they are good to work with a chip size like this. And here is the chip itself. So we need to do the same thing with the original instrument cluster, get the EPROM out of it, and then solder it to this circuit board. First, I'm gonna put this chip into this bag to be sure I will solder back the correct chip, because I had a few times soldering back the same chip I was desoldering out, so I don't want to repeat this experience anymore. And we're gonna put it right here. So here it is. I want to mention that I took a photo before desoldering it to be sure I will put it in correct position, because if you will put the EPROM vice versa and in the incorrect position, it could damage the chip. So let's take the old one out. That's the parts of the new one, and we're gonna disassemble this the same way. To get access to our circuit board, we'll need to get out all of these screws. All the screws are out. Now we need to disengage these plastic clips. We can do it using any tool, or we just can use our fingers. Doesn't matter because it's pretty easy. Yeah, so here it is, it's out, and we have the access to the circuit board. Now we need to get this chip out and put it to the new circuit board. So now we can compare that we have two exactly same circuit boards with all the part numbers matching. I mean these numbers and these numbers, and all the components on the board are the same, so we are sure we are safe to put this EPROM chip from this board, from original board, to the donor. As you can see, the chip is covered with a protection cover layer of the substance that could be removed from the chip using something like I use, or we can use any chemicals like some kind of cleaners or anything like this, but I don't like to use it here because, as you see, all the microcontroller unit legs are also covered by it, and if we will use any chemicals we will flash out all the protection surface and from the EPROM and from the MCU. So in this case I prefer to go just one by one, very careful getting this thing out to let the flux get to the chip. I think that would be enough to do our job, because as you can see we have direct access to the pins and to the contact pots, to the legs, name it like you want to name it, but I mean this stuff. Yeah. Okay, let's desolder it. Okay guys, the job is done for right this part of the job. We got the original EPROM out of the circuit board, and now we're gonna transfer it here. So why didn't I use Kapton tape here? Because I don't care about this circuit board, it's already dead, and all I need is just the EPROM, and that's all. The chip is on the board, so I can see it positioned correctly and everything looks pretty solid. So we can move the tape out and use a contact cleaner, that's an electronic contact cleaner, to wash the rest of the flux. Okay, so now it's good, clean, dry, no flux. so we can put the cover on and throw it into the car. Okay, we're throwing the modified donor cluster into the car. Looks like it should be positioned like this. Yeah. So now we need to connect the plug. Okay. Okay. Issue, we don't have the mileage. That's bad. Okay, since we know it didn't work for us, I want to do a few things right now. I want to desolder out the original EPROM and solder back the donor EPROM. Throw this cluster to the car and see it shows the donor mileage. It was about 154,000 miles. The chip is out, here it is, and the next thing I want to do, I want to just connect it without EPROM to the car and see what mileage reading we will get. Will it just turn on or not? What's going on? I just want to check the bad connection version, so maybe we had a bad connection for this EPROM to the circuit board, and we will have the same result without the EPROM, and it will show us that it makes sense to check the connection, check the chip, is it alive or not. Maybe that's the reason why it doesn't turn on, why that the EPROM chip itself is dead. I don't know. We'll go there. First of all, we'll try to connect it without EPROM, then we'll try to read the EPROM, the one and the other. We'll see what the difference is, where in the file could be the odometer reading located, and how to change it. Okay, so I installed the cover without screwing the bolts in. I don't think it's a good time to assemble it completely back. We're going to the car to see what's going on. Okay, so let's see what we'll have when we will turn the power on. Okay, so the cluster is on. Yep. And we have the same zero reading on the odometer. Looks like we have the same situation as we're having with the EPROM soldered to the board. So that's really interesting. That means maybe we had a bad connection or something was wrong with the EPROM chip. What I want to do now, I want to solder back the donor's EPROM to the donor's circuit board and see what's going on with the odometer. So here we have two circuit boards, two EPROMs. Okay, so we prepared the pads. Now let's add some flux and solder back the donor's EPROM to the donor's circuit board. So the chip is back, the donor's chip on the donor's board. Let's go and check the mileage. Okay, we have the mileage. That's good. That means one of the EPROMs is still alive as a minimum. Yep. So let's solder back the original EPROM to the donor's board and see what's going on. Donor board, original EPROM. Let's give it a try. Yep. That was a bad connection. we have an odometer reading. It's 339,731 miles in original cluster, and as you remember, we've seen 154,000 miles in the donor cluster, so that would be like a false reading. And if this odometer would have a false reading, on the next inspection would be suggested that the vehicle that has a wrong odometer reading, and it should have a wrong odometer reading title. I think that's a success. So we're half away from there, almost there. This side done. We're there. Everything is on its places. Let's check one more time the result. Here we go. Nice. As soon as the instrument cluster is working, we're able to see the warning lights that are on, and that's the ESP warning light, or VSC for Toyota, Vehicle Stability Control, and that's the reason why it has this warning light. The steering angle sensor is not responsive, so as you can see, any turn of the wheel doesn't change the steering angle sensor reading, so it means that the steering angle sensor is bad after collision, I believe, and it needs to be reprogrammed. So if the customer would be willing to reprogram it, we'll do it. The code that he gets, C1231 steering angle sensor circuit.